Okay, so imagine this, right? You've got an empty tank just sitting there in a yard.
Yeah.
Maybe a manhole cover on the ground. Or even some, just complicated-looking pipes in a plant somewhere. Looks pretty harmless, right?
Yeah, at first glance.
But here's the thing. What if I told you that those seemingly safe spots could actually be some of the most dangerous places you could end up? Because that's the reality of confined spaces.
They can be invisible killers, really.
Totally. And so often you hear people making assumptions like, oh, it's just empty or I'll just be in there for a minute. But that kind of thinking, that's playing a really dangerous game.
A high-stakes gamble, for sure.
Absolutely. So in this deep dive, we're going to break down those assumptions and look at what it takes to control the air in these kind of deceptively dangerous areas.
Yeah, you hit the nail on the head there. We're not talking about those obvious in-your-face hazards. It's the hidden stuff, the invisible air quality risks that make confined spaces so tricky. And like you said, that whole idea that a quick peek or an empty tank equals safety, that's often what leads to those awful incidents, right? So what we want to do is give people the knowledge to manage those unseen dangers proactively.
Exactly. And that brings us to the very first step, and it's one you just can't skip. Risk assessment. Now, I know sometimes risk assessments can feel like just another box to check, another form to fill out.
Yeah, I get it.
But honestly, this is different. This is about setting up your main line of defense before anyone even thinks about stepping foot into one of these spaces. So when we talk about a risk assessment for a confined space, what are we actually trying to understand? What's the core question here?
Well, I always try to frame it this way. What's the worst that the air in there could do to you? And how likely is that to happen? Because those two things, that helps you figure out what to test for and how to ventilate. It's all about gathering info about those potential hazards lurking in that confined space before anyone goes in. What could go wrong with the air? Could there be not enough oxygen? Maybe other gases have taken its place, or a process like rust has used it all up. And then there's the flammable gases, things like methane, which can build up underground, or vapors from solvents if, say, the space was used for painting or cleaning in the past. And of course, we have to think about toxic gases, like hydrogen sulfide, which you often find in sewers or near decaying stuff, or carbon monoxide, which comes from things burning incompletely. And the scary thing is, these gases can be there even if you can't smell or see them.
So it's not just about what the space is like right now, at this very moment. It's about understanding what could be present based on how it's been used before or what you're planning to do in there.
Exactly. You've got to consider any residues that might still be hanging around. Even if a tank looks empty, there could be those invisible vapors. And then there's the work itself. Are you going to be welding, painting, using certain chemicals? All that stuff can bring in new hazards or make existing ones worse. So to do a good risk assessment, you have to really understand the space's history and what you're going to be doing in there.
Okay, so we've done our risk assessment, and what's that absolute must-do next step before anyone even thinks about going in?
Atmospheric testing every single time.
No exceptions?
Nope. You can't just go on your gut feeling or what you think might be true. You need hard data about that air, and don't just stick a sensor in the entrance and call it a day.
Right.
You've got to test at different levels inside the space, top, middle, bottom, and there's a really good reason for that.
I think I know where you're going with this. Different gases have different weights, right?
You got it. Some gases, like methane, they're lighter than air, so they might be up near the top. But others, like that hydrogen sulfide we talked about, they're heavier and sink to the bottom. So if you only take one reading, you might think everything's fine when it's not.
Totally. You could have perfectly breathable air at the top, but a pocket of, deadly gas at the bottom where someone might be working.
Exactly. So testing at different levels gives you a way more accurate picture of what's going on with the air throughout the entire space.
Okay, so let's say we've done our assessment, we've tested the air, and, we found a problem. Maybe there's not enough oxygen, or there are flammable gases, or there's some toxic stuff in there. That's where ventilation or exhaust comes in. So why is that so important? What are we trying to do by moving the air around in these spaces?
Basically, ventilation is the main way we make a confined space safe to enter. It's how we deal with those specific hazards we found in the risk assessment. And there are three big goals here. First, we've got to make sure there's enough breathable air. That means getting the oxygen level up to a safe zone, which is usually between 19.5% and 23.5%. If it's too low, people can get something called hypoxia, which can be really dangerous, even deadly.
Yeah, our bodies need that oxygen to work, right?
Absolutely. So ventilation helps to replace the oxygen that's been used up or pushed out.
Makes sense.
Yeah.
So what's the second reason for ventilating?
The second thing is to manage those flammable hazards. If we find flammable gases or vapors, we use ventilation to dilute them basically, to spread them out so they're below their ignition point. Usually we aim for less than 10% of the lower explosive limit, or LEL. That 10% mark gives us a safety margin. Basically below that, even if there's a spark, you shouldn't get a fire that keeps burning.
So you're making it much less likely that there'll be an explosion.
Right. And the third reason for ventilating is to get rid of toxic gases and other bad stuff. The goal here is to get the concentration of those substances down below the safe limits. These limits can be different depending on what the chemical is and where you are. You might hear people talk about PELs, permissible exposure limits, or VLEPs, which is basically the same thing in French. These are the legal limits for how much of a certain toxin can be in the air. The important thing is to get those levels down so that no one working inside gets sick.
So ventilation is kind of like scrubbing the air clean so it's safe for people to be in there and do their jobs.
Yeah, that's a good way to put it.
Now, the material we've been looking at talks about two main approaches: supply ventilation and exhaust ventilation. What's the basic difference between the two?
Sure. Supply ventilation, as the name suggests, is all about forcing clean air into the space. This creates what we call positive pressure, which pushes the old, potentially dangerous air out through any openings or through exhaust points. Imagine filling a room with fresh air, right? The stale air has to go somewhere.
So you're essentially flushing out the bad air with the good. What about exhaust ventilation?
Exhaust ventilation does the opposite. It sucks the contaminated air out of the space. This creates negative pressure, which pulls fresh air in from other openings. Exhaust ventilation works really well when you know exactly where the contamination is coming from, like if you're doing welding in a specific spot. You can put the exhaust duct right near the source to capture those fumes.
So supply is more about diluting the entire atmosphere, and exhaust is more targeted. Is one generally better than the other?
It really depends. The best way to go depends on the space itself, the kind of hazards you've got, and what kind of work is being done. Sometimes the best solution is to use a combination of both. That's what we call a push-pull system. You push fresh air in at one end and pull the dirty air out at the other, creating a constant flow of air through the space. But no matter which method you use, the goal is always the same: to make the air safe for people to be in there.
Right. Makes sense. So let's say we've decided on our ventilation strategy. Now we need to choose the right equipment, specifically the fans. What are some of the key things to consider when picking out those fans?
Well, the first thing is flow rate, which basically tells you how much air the fan can move in a certain amount of time. It's measured in CFM, which stands for cubic feet per minute, or M, which is cubic meters per hour. And you need to get a fan that's powerful enough for the size of the space and how bad the hazards are. A small fan in a big contaminated space just won't cut it.
Gotcha. So it's all about getting enough air exchanges to either dilute the contaminants or get them out completely. I know the material mentioned air changes per hour and dilution calculations. Can you explain those a little bit more?
Sure. Air changes per hour, or ACH, tells you how many times all the air in the space is replaced with fresh air in 1 hour. Depending on the hazard and how risky it is, you might need a certain number of ACH to make the air safe. Dilution calculations are a way to figure out how much fresh air you need to bring in to lower the concentration of contaminant to a safe level. But remember, these are just estimates. The only way to be sure the ventilation is working is to test the air with a calibrated gas monitor after you've been ventilating.
Right. So those calculations are a good place to start when choosing equipment, but the real proof is in the testing. What about the type of fan? The material talked about axial versus centrifugal fans. What's the difference in practice when it comes to ventilating confined spaces?
Axial fans, they kind of look like airplane propellers.
Oh.
They're great for moving a lot of air quickly when there's not much resistance. They're usually used when you need to ventilate a space that's not very deep and doesn't have a lot of ductwork. Centrifugal fans, sometimes called squirrel cage blowers, are better at handling resistance, like from long ductwork. They can generate more pressure, which you need to push or pull air through longer distances or more complicated systems, like if you've got a long, winding sewer to ventilate, a centrifugal fan is probably going to be your best bet because it can overcome that resistance. So really, it comes down to the layout of the space and how you're going to be moving the air.
That makes sense. If you need long ducts to reach a certain part of the space, a centrifugal fan is probably the way to go. Okay. Now, this next point, it was really stressed in the material, safety rating, specifically using explosion-proof or intrinsically safe equipment. Why is that so crucial?
This is non-negotiable if there's any chance at all that flammable gases or vapors could be present, even if it's just a potential you identified during your risk assessment. Regular electrical equipment, it can spark or get hot enough to ignite a flammable atmosphere, and that can cause a huge explosion. That's why, if there's that risk, you have to make sure that your entire ventilation system, the fan, the motor, the ducts, even the electrical connections, is rated as explosion-proof or intrinsically safe. Those ratings mean that the equipment is designed so that it can't cause a spark or get hot enough to start a fire. And you also need to ground everything properly to safely get rid of any static electricity. Using regular equipment in a space that could have flammable stuff in the air, it's like playing with fire. Seriously, there's absolutely no room for error when it comes to this.
That's a sobering thought. You can't mess around with that. What about the air intake in the discharge? Where should you be pulling in the fresh air, and where should the contaminated air be going?
The intake for your ventilation system needs to be in clean, fresh air, well away from anything that could contaminate it. So, think exhaust fumes from cars or generators or any areas where there might be pollutants. The last thing you want to do is pump contaminated air into the confined space. And the discharge, where the bad air comes out, that needs to be thought about carefully too. You need to point it away from where people are, walkways, and any air intakes for other buildings or ventilation systems. The idea is to get the hazard out of the confined space without creating a new hazard somewhere else.
So you're not just moving the problem around, you're actually getting rid of it.
Right. And finally, there's the ducting. It might seem simple, but there are some important things to remember when you're using ducts for ventilation.
Yeah, what about ducting?
Well, you need to use the right size duct so you don't restrict airflow and make the fan work harder. Keep the ducts as straight as possible and avoid any sharp bends or kinks. Those create resistance and slow down the airflow. Make sure all the connections are tight so there are no leaks. And most importantly, make sure the duct reaches the part of the space that needs ventilation. Just having a duct opening near the entrance might not be enough if the hazard is further inside. If the ducting is poorly designed or installed, it can make even the most powerful fan useless.
Makes sense. It's all connected. So let's put it all together. We've done our risk assessment, chosen our ventilation method and equipment, and set it all up correctly. What should we expect to see? What does a well-ventilated, confined space look and feel like? And more importantly, how do we know for sure that it's safe to go inside?
The end goal is to have a verified safe atmosphere. And that's not just a feeling, it's something you need to measure. After you've run the ventilation for a while, you need to test the air again with a calibrated gas monitor before anyone goes in. You need to check that the oxygen level is good, that any flammable gases are well below that 10% LEL mark, and that any toxic contaminants are below their limits. Those readings are your proof that the ventilation is working.
And it's not just a one-time check, right? I remember the material saying that you often need to keep ventilating even while people are working inside.
That's right. Things can change inside a confined space. The work that's being done could release more contaminants, or the ventilation system itself could stop working. That's why it's often required to keep monitoring the air while people are inside. Someone should be checking those gas monitor readings regularly. Safety in a confined space isn't a set it and forget it thing. You need to be paying attention all the time.
Okay, so to quickly recap everything we've talked about today, we started with the importance of risk assessment, then we talked about why we ventilate, to make sure there's breathable air, to deal with flammable stuff, and to control toxic substances. We talked about the difference between supply and exhaust ventilation and how to choose the right fans, thinking about flow rate, fan type, that crucial safety rating, and making sure you're getting the air from the right place and sending it to the right place. And finally, we stressed that the goal is to have a verified safe atmosphere, which you check by testing the air after ventilating, and to remember that you often need to keep monitoring the air while people are working. It's a long process, but like we said at the beginning, those dangers are real.
You said it. But if you have the right knowledge, the right equipment, and you follow these steps, you can make confined space entry a whole lot safer. There's just no reason to guess or cut corners when people's lives are at stake.
Absolutely. So as you're thinking about everything we've talked about, and maybe thinking about your own experiences, what would you say is the biggest challenge you've faced when it comes to dealing with confined space ventilation on your job sites?
You know, there are so many things to think about, and I'm sure our listeners have come across their own unique challenges too. We'd love to hear about those.
And if you're looking for more specific safety guidelines, I'd really recommend checking out resources from organizations that focus on construction safety and confined space entry. Look for ones that are specific to your industry and where you are. Keeping up with the latest best practices that's so important in this field.
For sure. And when it comes to confined spaces, always remember, don't assume, verify. Ventilate effectively and make sure you have a verified safe atmosphere every time.
Couldn't have said it better myself.
Stay safe out there.
You too.